Hi, once again. Let me try to solve the problems on some of the Fourier transforms, which is a very good topic. Okay, right now, let us try to solve the problems for that. Okay, let us see that. Now, uh, let us find let us find the Fourier transform, okay, of the function. Fine, which is f of x. Okay, I have function this 0 1 0. Now for x less than equal to a, and for a less than x less than b. Okay, for x greater than b. Now that we have f of alpha, okay, which is 1 by square root of 2 pi integral minus infinity to infinity f of x e to the power of I alpha x dx. Okay, this is formula. Okay, we'll be using now for the limit, which is uh, a to b. Okay, in a real line, if you have minus infinity here and plus infinity, we have a and b. Okay, so let us put that limits. Okay, so your f of alpha will be 1 by square root of 2 pi integral a to b, okay, which is f of x. So since you have 0 and 0, the extreme ends, so I'll be considering a to b. You have, that is 1 into uh, 1 into e to the power of I alpha x dx. Fine. Okay, now we know that into the integral of e to the power of mx will be e to the power of mx divided by m. Let us put that. So let me put here right into. Okay, let us put that here. So what do I get? So this will be 1 by square root of 2 pi. Okay, so and if I put the limits, which is a and b, I get e to the power of I alpha b minus e to the power of I alpha a divided by I alpha. So that's what I get after putting the upper limit and the lower limit. So I can write 1 by I as minus I. I'll write 1 by I as minus I. Fine. So if I substitute that, so I get minus I, okay, divided by alpha square root of 2 pi, okay, which is e to the power of I alpha b minus e to the power of I alpha a. This is your f of alpha. Fine. So let us move on to next problem once this is done. Okay, for any queries, please contact to my email ID. Yes, let us continue to solve some more of the Fourier transforms for the function. Okay, it is given to you. Let us find that. Now I have to find the Fourier transform for the function which is f of x, which is sine x 0 for 0 less than x less than pi, otherwise. Now for 0 to pi, let us substitute it. So f of alpha, this is 1 by square root 2 pi, okay, integral 0 to pi, okay, f of x being sine x alone, fine, because you don't have another function, so I'll be having only for 0 to pi, I'll have only sine x. Now, this will be e to the power of I alpha x dx. Now, this is of the integral of the form e to the power of ax sine bx plus c dx. Okay, we have a formula for this. Let us substitute that formula and try to execute this problem. Okay, let us see how it goes. So this will be 1 by square root of 2 pi, fine, and this will be e to the power of I alpha x divided by, now a being alpha, so that will be and I alpha, so I alpha whole square plus b square, which is 1, okay, because a sine of x, okay, sine bx plus c, so b will be 1, okay, so that's that. And we have I alpha sin x minus cos x over the interval 0 to pi. Okay, so let's further continue to solve the problem. Okay, if you have any queries, you can ask or send a comment on this also. Okay, let us continue the problem. Let us put the upper limit and the lower limit. Let us substitute those limits now. So if I substitute that limit, I get 1 by square root of 2 pi, 1 by 1 minus alpha square. Okay, so this will be integral. If I put the limit, so this is e to the power of I alpha pi. This will be I alpha pi, and brackets I alpha sin pi, I alpha sin pi minus cos pi. Okay, minus I get and this will be I alpha sin 0 minus cos 0 plus the brackets. Now I have put pi and then afterwards 0. So now we know that cos n pi is minus 1 to the power of n, and cos pi will be minus 1, and sin n pi is 0, sin pi will be 0, Okay, so we have also sine 0 as 0. Okay, let us substitute that, cos 0 being 1. Okay, let us substitute those things, which is to be substituted here for this problem. So when I substitute it and try to calculate this entirely, so I'll be left, sine pi will be 0 and sine 0 is 0. Only I'll be left with cos pi, which is minus 1, so minus of that, so gets outside, and I will get e to the power of, okay, by e to the power of I alpha, okay, plus 1. Okay, get this. Now further, if I try to solve this, so e to the power of I alpha will be cos alpha pi plus I sine alpha pi. Let us substitute it. So I get 1 by root 2 pi, 1 by 1 minus this, and this will be cos alpha pi plus I sine alpha pi. Okay, this is plus 1. Further, if I simplify it, okay, so I can put this term as a side. This will be cos alpha pi, okay, plus I sine alpha pi, okay, visible, yeah, divided by square root of 2 pi 1 minus alpha square. So this will be the solution for this transformation. Okay, let us again find next problem on Fourier transforms. I'll be doing some more problems also. Okay, once we try to understand these concepts. Okay, now let us find Fourier transforms for the function which is f of x, okay, which is 1 plus x by a, okay, 1 plus x by a, and we have 1 minus x by a and 0. This is for minus a less than x less than 0, and this will be for 0 less than x less than a, and this is for otherwise. Okay, let us try to solve this now. Fine, let me continue to solve this. Now we know the formula, it is minus infinity to infinity f of x e to the power of I alpha x. Okay, fine. Now put directly f of alpha 1 by square root 2 pi, fine. So this will be integral minus a to 0 1 plus x by a e to the power of I alpha x dx plus integral, this will be 0 to a 1 minus x by a e to the power of I alpha x dx. So that's that. Let us further continue to solve this problem. Now we have the uh, two terms here, and the third term being 0, so we need not consider that. Okay, because in a real line you have minus a and a, so we have 0 here. Okay, that's what we are looking into. Okay, further let me try to solve this. Fine, let me try to solve this. Now I have the upper limit, which is 0, and the lower limit, which is minus a. Before that, let me try to integrate this completely. So I get 1 by square root of 2 pi. Okay, so within this curly braces, first term is 1 plus x by a. Fine. First term is x by a, and e to the power of I alpha x by I alpha, we get this, and minus 1 by a. Okay, close the brackets. Now integrate twice, I get e to the power of I alpha x divided by I alpha x alpha whole square. Okay, and don't forget the limits, which is uh, minus a to 0. Fine. Okay, then we have 1 minus x minus a. Let us find that. So that is 1 minus x minus a e to the power of I alpha x by I alpha. This is minus, this is again, this is minus 1 by a. This is e to the power of I alpha x by I alpha whole square. So this is 0 to a. Close the curly bracket. Okay, now let us put the upper limit and the lower limit. First, for this, quickly, let us put this. So I get 1 by I alpha plus 1 by a alpha square, and this is 1 minus e to the power of I alpha x. Okay, alpha x being this, so I a alpha, I a alpha, I a alpha. Okay, minus 1 by I alpha minus 1 by a alpha square, and e to the power of I alpha a, okay, minus 1. Close the braces. Okay. Uh, any queries? No. So let me uh, try to continue solving this problem. Okay. So this is 1 by root 2 pi. Okay. So this is 1 by a alpha square. Close the curly brace, open that curly braces. This is 2 minus e to the power of I a alpha. This is minus, and we'll have e to the power of I a alpha plus. Close the braces. Okay. So minus, we'll get this as plus. Okay. Now further simplify. So this is square root of 2 by pi 1 by a alpha square, and this is 1 minus cos a alpha. Okay, So I have put the formula cos hx as e to the power of I, and simplifying cos I and alpha. So I get this result. Okay. So please, if you have any queries, you can ask. Okay. This is very, very important problem. Okay. Let us find next problem. Okay. Let us try to solve it. Okay. Now, let us find the Fourier transform for the function, okay, which is Fourier transform of f of x, which is f of x being e to the power of minus x square by 2. Let us find this. How do we solve this? Again, we have formula f of alpha, which is equal to 1 by square root of 2 pi, okay, uh, minus infinity to infinity, f of x being e to the power of minus x square by 2 e to the power of I alpha x into dx. Now, since we have exponential for both, let us try to concentrate on the powers of those exponentials and try to simplify it. So this will be 1 by square root of 2 pi integral minus infinity to infinity, fine, e to the power of minus 1 by 2 if I take it outside. So I'll be left with x square minus multiply and divide by the 2, you'll get a 2I alpha x. If I take it inside, I'll get the same result into dx. I can further simplify it. So, concentrating only on those, uh, the x square minus 2I alpha x minus I alpha whole square plus alpha square. Okay. So, already I have curly braces. Okay. I have minus alpha. So, e integral minus infinity to infinity. So, this is 1 by square root 2 pi. Okay, f alpha dx. So that's what I get. Now we have this whole part and this part. So this will be alpha square by 2 and minus. You take this outside. Okay, so let me put that. Okay, completely. Okay, let me try to simplify that. Let me try to simplify it now. So what do I get? So f of alpha, f of alpha, okay, so e to the power of minus alpha square by 2 divided by root 2 pi, okay, is it visible? Yes. Integral minus infinity to infinity e to the power of minus half into x minus I alpha x whole square into dx. Okay, I get this. Now let us put what y is. Y is x minus I alpha x. Okay, I alpha. Okay, this one be x. So this is I. So by root 2, if I consider this. Okay, let us substitute whatever I mentioned here. So this is e to the power of minus alpha square by square root 2 pi. This is minus infinity to infinity. So since the limits won't change, so e to the power of minus y square, okay, to the minus y square square root 2 dy. Okay, now if I cancel these two, so I have this result as e to the power of minus y square as root pi by 2. Okay, so e to the power of minus alpha square by 2 by root pi. So uh, I'll be getting by 2. So I'll be having that, right? And this is 2 times. Okay, that is for uh, minus infinity to infinity f of x you have dx, so that is 2 times 0 to infinity. Okay, f of x dx, right? So 2 gets cancelled, pi gets cancelled, so I'll be having f of alpha, which is e to the power of minus alpha square by 2. So this results. No, if you notice that f of alpha is minus alpha square by 2 and f of x is e to the power of minus x square by 2. So that is the transformation which we have done. Okay. So let us see one more problem. Okay. Now let us change another topic which I'll be discussing now. So, and then we'll close the session. Okay. I'm trying to solve this because I've got queries on that, so I'm doing trying to solve. Okay. So let us find the appropriate root of the function. Okay, by using Newton-Raphson's method. So suppose if I have x cube minus 3x plus 5 is equal to 0. Okay, if I have this, uh, fine. If I have this, to find the appropriate root for this function. Okay, let us try to solve this by using Newton-Raphson's. Okay, and I'll be given as x as 2. Okay, so this is the initial value or the first uh, I mean the initial value of for the root, okay, which is 2. Okay, now since this has been considered as f of x, so f dash of x will be 3x square minus 3. Okay, which can be written as 3 of x square minus 1. Okay, now let me directly put the solution for this. So I'll write the formula: xk plus 1 will be xk minus f of xk divided by f dash of x cube. Okay, this is the formula now. Okay, now since we got x naught as 2, okay, so put k is equal to 0, I get x1, this is x naught, and this will be f of x naught divided by f dash x naught. Okay, let us substitute that. So x naught being 2 minus, when you substitute this here, you get 2 into x cube. Okay, let us substitute that here. So if I simplify it, okay, 2 into x cube, x being this 3 plus 5 divided by 3 times of x naught 2 square minus 1. So if I simplify it, I'll get 21 by 9. Fine. So that is 2.333. Let us find what is x2. This is 2 again. So I mean, we got the next result, which is x2. That is substituted. Okay. So I get 2 into, fine, you're able to understand, right? I'm getting queries. I'm trying to answer those queries. Okay. Okay. Yeah. Yeah. Let me continue. Okay. So this is 2 into 2.333. You can take four decimal places. Q plus 5 divided by 3 into 2.333. This should be x1. So this is x1 is 2.33. Don't forget that. This is whole square minus 1. Simplify it. I get somewhere around 2.28055 after simplifying it. Like that, you find what is x3. I get 2.27902. Okay, so you have to do the approximation till we get the previous value, which is almost the same up to given decimal places. So I get x4 as 2.27902. So this will be the root. Fine. Okay, let me end the session, and please post your comments. Your comments are very important for us, and basing on this, I'll be doing live solutions, trying to solve those. And thank you for listening.